When we look up at the night sky, we can see roughly 6,000 stars with our naked eye. However, this number is just a fraction of the real number of stars in our galaxy alone. The Milky Way is home to 1 trillion stars, and it's just one average-sized galaxy in a universe containing 200 billion others. Which means out there are 200 billion trillion stars. So it begs the question, are we alone? I'm Damon Scotting, and this is Astronomical. Now in astronomy, we often use the numbers millions, billions and trillions. But these are huge numbers. We don't use them in everyday lives. Except when Chris buys 4.2 billion apples and Paige needs to borrow 168 million. But even then, that's only on maths tests at high school. So in order to make you understand how truly large the numbers in astronomy are, I'm going to write it out for you. So, in our galaxy alone, there are 1 trillion stars. A lot of stars. How many exactly? Well, that's 1 with 12 zeros after it. 3, 4, 5, 6, 7, 8, 9, 10, 12. That's how many stars there are in the galaxy, the Milky Way galaxy. 1 trillion. 1 with 12 zeros after it.
The number of stars in our galaxy is immense. It isn't possible to simply look up at the night sky and count all the stars. So the total number in our Milky Way galaxy could be anywhere between 100 billion to 1 trillion.
Now that was just the stars in our galaxy alone. And ours is just an average sized galaxy in a universe containing 200 billion. Now that's 2 with 11 zeros after it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how many galaxies there are in the universe.
Although a smaller amount, the number of galaxies is far harder to predict. Despite being hundreds of thousands of light years in diameter, most galaxies are invisible to us. They are beyond our current scope. Some are so far away and dim that we don't currently have the necessary tools to see them. The number 200 billion comes from an average based on the Hubble Deep Field. The image represents 1/32 millionth of the night sky, and there were roughly 5,500 galaxies within it that we could see. So 5,500 multiplied by 32 million means there are almost 200 billion galaxies in the observable universe.
So that's 1 trillion stars in the average galaxy. And there's 200 billion galaxies in our observable universe. So that means the total amount of stars in our universe is 2 times 10 to the 23. That's 2 with 23 zeros after it. Okay, so that's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's it. That's how many stars there are in the observable universe. And we're just 1. 1 in 200 billion trillion. And there it goes, washed away in a matter of seconds. And that's all we are. We are just a drop in a vast ocean. We're a grain of sand on an endless beach. We're nothing. On the grand scale of the universe, we are tiny. And there's 2 things you can do about that. Number 1, you can feel scared. You can feel worried by the fact that we may be alone in this great, vast space. And if we're not alone, maybe that's even scarier. Or you can grab it by both hands. You can make the most of the fact that we might be the only life out there. We are precious. We're unique. We are special. And we need to make the most of that.
Now 200 billion trillion stars is an astronomical figure. It is far beyond the comprehension of any human being. The potential for life seems to be limitless. So the question is, where is it?
Now, given the vast amount of stars in our universe, it seems difficult to believe that our planet is the only one capable of supporting life. So how do we discover new worlds that are similar to our own? Well, when we look up at the night sky around different stars, we observe a region known as the Goldilocks Zone. This is a point around a star where the temperature isn't too hot and it's not too cold. It's just right. Now, if a planet is too close to its star, liquid water wouldn't last long and would boil away from the surface. That is true for Mercury and recently Venus. In fact, in the early stages of the solar system, just a few hundred millions of years after the birth of our sun, Venus was believed to have once had liquid water on its surface. But back then, the sun was 70% of its size that it is today. So as it grew in size, the water evaporated. And as it did, it added water vapor to the atmosphere, which led to a runaway greenhouse effect on the surface of Venus, which turned it into the hellish world we know today. Then, going out towards the edge of the solar system, we reach Mars. Now, Mars is far too cold for liquid water to exist on its surface. Although it can have temperatures as high as 27 degrees Celsius, on average they're around minus 60 degrees. And we can see from the surface of Mars that there was once riverbeds where water flowed, but now they are dry. Which leaves us with our planet, planet Earth, where the temperatures are just right for liquid water to exist. And indeed, life does thrive here. So now we know where we should be looking around stars for the right kinds of planets that could harbour life. How do we spot them? How do we know which stars have planets? After all, planets don't give off light, they merely reflect it, and stars are incredibly bright. So how do we detect exoplanets? How can we find planets that orbit around other stars? After all, stars are very bright, but the planets that orbit them give off no light whatsoever. So rather than look out for points of light, we look out for the absence of it. By measuring a star's brightness over a long enough period, we notice dips. These dips occur when the planets orbit in the right plane to us here on Earth. And by measuring the intervals at which they occur, we can determine the size of the planet, the distance it is from its star, the length of its year, and most importantly, whether or not it could harbour life.
Given this information, it seems rather easy to determine whether or not there are habitable worlds orbiting a star. This method of discovering exoplanets has proven successful ever since the first detection was made back in 1992. As of the 1st of May 2020, there are 4,260 confirmed exoplanets in over 3,000 systems, with 22% of those systems having more than one planet. We have still only analysed a very small portion of the stars in our own galaxy, but the results so far are extremely promising. So if there really is life out there, why haven't we heard from it?
So now that we know there's potentially alien life out there nearby in the galaxy, how do we communicate with it? How do we make contact? Our best method is probably through radio waves, which travel at the speed of light through the vacuum of space. But our nearest star, Proxima Centauri, is 4.26 light years away from us. That means even sending a signal as fast as the speed of light, it will still take 4.25 years before it reaches our nearest exoplanet. Assuming it has life and they have the abilities to respond and send another message, we wouldn't know for another 4.25 years. So from the time we sent our initial message saying a simple hello, it'd be 8.5 years before we got a reply back. So so it's very hard to communicate over the vastness of space. But what about intelligent civilizations getting into contact with us? Have we ever picked up a signal from another species? Well, on August 15th, 1977, something very strange happened. A man named Jerry Amon picked up an unusual signal using the Ohio Big Ear radio telescope. Now in the 50s, astronomers decided that if an intelligent life form was to communicate with us, they would do so on a very specific frequency, 1420 megahertz. Now this is special because its wavelength is 21 centimeters, which is the same as that of hydrogen, the most abundant element in the universe. So they set aside this frequency, and only they could specifically communicate at this wavelength. They pointed their radio telescopes towards the constellation of Sagittarius, and they listened out. Then, on August 15th, 1977, 2 days after the measurement was taken, Jerry Amon analysed the measurements, and to his bewilderment, he discovered this anomaly. He wrote down 3 letters next to it. This is the WOW signal, and it's still today our strongest evidence of communication from alien life. But it was almost 50 years ago, and since then we have pointed far more sensitive telescopes towards the same region of the sky, and we're yet to hear anything back. One of the beautiful things about science is that we don't just take things as a given. In order for things to be considered as true evidence, they must be repeatable. So sadly for now, the WOW signal is just a one-off. But one day, we will pick up another one. Maybe from the same region, maybe not. But this is encouragement to keep on listening out.
There's plenty of reason to believe there is life out there in the universe. But the real question is, are they intelligent enough to communicate with us?
So what is the likelihood that we are all alone in the universe? Out of the 200 billion trillion stars there are, we are all there is in terms of intelligent life. There are believed to be more stars in the observable universe than grains of sand across all of the Earth's beaches. So can we really be the only form of intelligent life out there? Well, one man decided to try and answer this question. This is a Drake equation, developed by Dr. Frank Drake, one of the founding fathers of SETI, the search for extraterrestrial intelligence. It determines how many intelligent civilizations there are in our galaxy that we could discover today. And it starts off with the number of stars that are formed every year in our galaxy. The next variable is the number of those stars that have a planet orbiting them. We believe this number to be 100% or very close to it. This is followed by the number of those planets that are capable of developing life. Then the number of those planets that are capable of developing intelligent life, those of which will be able to communicate with us. And then finally, perhaps most importantly, the longevity of those forms of life. How long the civilization will last before wiping itself out. Now this is very hard to determine because we have nothing to base it on. And if we try and base it on ourselves, the number is very low. Because as an intelligent species that's been able to communicate, we have existed for the blink of a cosmic eye. Now this equation is often the topic of hot debate, because all the variables can give a wide variety of answers. A pessimist would say there are no other forms of intelligent life out there in the universe. Whereas an optimist might look at this and determine that civilizations could last in the order of billions of years, in which case there could be trillions of planets in our universe. Trillions of other forms of intelligent life able to communicate with us. A vast network. And if that's the case, the universe is a very exciting place. And it might seem scary that there's lots of different forms of life out there, but it might seem even scarier that there are no forms of life out there, and that we are all alone.
If we are not alone, then the next question is, what would other forms of life appear as?
So what do aliens actually look like? Well, in the movies, they're depicted in a variety of different ways. They often have a large number of legs, arms, eyes, and most importantly of all, a big brain. I've asked people to send in a few of their designs of what they think an alien looks like. And a general trend is that they're usually green people with lots of arms and lots of legs, as well as plenty of eyes and often tentacles. This is a design that my best friend Paige did. And as you can see on her world that is covered in burgers and nugget trees, the species that live on here have a variety of legs and arms. But there's a strong reason to believe that aliens might not be so dissimilar to us as we might think. The reason they stretch our imagination is because we've never seen them before, and we imagine them to be complex beings. But in reality, they need to be the same as us in order to survive. In fact, there's a number of things you will likely need in order to succeed and top your planet's food chain. The first is an exoskeleton protecting the brain, the most important organ. The second is manipulative digits like fingers. These will allow you to hold tools. Binocular vision to judge distance. Between our eyes there is a parallax, so having two or more eyes allows you to tell how far away something is. The number of legs, arms and eyes is also very important, because too many will overload the brain. It will not allow it to focus on other areas. It is likely that if we discover another alien species, they will have more similarities than differences to us. No legs would lead to mobility issues. One leg would lead to balance issues. 2 legs is just about right. The same with 2 arms. And 2 eyes allows you to have binocular vision. So depending on the way you look at it, we might be the bare minimum you need. Or we might be too much. If we were to discover another alien species, then they might look similar to us. But if one was to discover us and venture through interstellar space, then it might be very different. The vacuum of space is a very harsh environment. We wouldn't last more than a couple of minutes in it. But when travelling through it, the spaces between stars is so vast that even travelling as fast as you could possibly go at the speed of light, it will still take you years to reach your nearest star. Which means in order to do so, you need to adapt to your environment. So it's likely that these cosmic voyagers who are visiting our little blue planet will have done so. Now the question, are we alone, is possibly the most profound question you can ask in science today. It is one that has not only puzzled scientists, but possibly every single human being to ever walk the planet. I can guarantee that at least once in your lifetime, you have looked up at the stars and wondered if there was life elsewhere, or if we are in fact all there is. And if you were to answer that question today, based on the evidence we have, then the answer would be a resounding yes. We are all alone. We are yet to find life elsewhere in our solar system, let alone the universe. And it might seem arrogant or maybe even ignorant to assume that we are all there is. But as a species, we are still very young. And we've explored so little. One day, in the future, we may receive another signal like the WOW signal. One day, we may venture to another solar system. One day, we may encounter alien life. And the knowledge we gain from those experiences will shape how mankind goes forward forever. We orbit around an average-sized star, which makes up an average-sized galaxy, which itself might make up a smaller than average-sized universe. It's possible that our universe is a mere drop in a sea of other universes. So I'll let you answer the question. Are we alone? I'm Damon Scotting, and this was Astronomical. Okay, when we look up at the night sky, we can see roughly 6,000 stars with the naked See how big that bat was? Yo! That was huge. Well, that's enough filming for forever.